Hi, and welcome to the next video of Section 1, the Tkinter Geometry Manager. In the previous video, we have learned about widgets, the building blocks of GUI programs. In this video, we will learn about Tkinter Geometry Manager. You may recall that we used the pack method to add widgets to the dummy application that we developed in the previous section. The pack method is not the only way of managing the geometry in your interface. In fact, there are 3 geometry managers in Tkinter that let you specify the position of widgets inside a top-level or parent window. The 3 geometry managers are as follows. Pack. This is the one that we have used so far. It is simple to use for simpler layouts, but it may get very complex for slightly complex layouts. Grid. This is the most commonly used geometry manager that provides a table-like layout of management features for easy layout management. Place. This is the least popular, but it provides the best control for the absolute positioning of widgets. Now, let's have a look at some examples of all 3 geometry managers in action. The Pack Geometry Manager. The Pack Manager can be a bit tricky to explain in words, and it can be best understood by playing with the code base. Frederick Lund, the author of Tkinter, asks us to imagine the root as an elastic sheet with a small opening at the center. The Pack Geometry Manager makes a hole in the elastic sheet that is just large enough to hold the widget. The widget is placed along a given inner edge of the gap. The default is the top edge. It then repeats the process till all the widgets are accommodated. Finally, when all the widgets have been packed in the elastic sheet, the Geometry Manager calculates the bounding box for all the widgets. It then makes the parent widget large enough to hold all the child widgets. When packing the child widgets, the Pack Manager distinguishes between the following 3 kinds of space. The unclaimed space, the claimed but unused space, the claimed and used space. The most commonly used options in Pack include the following. Side, left, top, right, and bottom. These decide the alignment of the widget. Fill, X, Y, both, and none. These decide whether the widget can grow in size. Expand. Boolean values such as tkenter.yes/tkenter.no, 1/0, true/false. Anchor. NW, N, NE, E, SE, S, SW, W, and center, corresponding to the cardinal directions. Internal padding, iPad X and iPad Y, for the padding inside widgets, and external padding, Pad X and Pad Y, which all default to a value of 0. Let's take a look at a code that illustrates some of the Pack features. 2 of the most commonly used Pack options are Fill and Expand. The following is the code. This is a description of the code which we are using. When you insert the A button in the root frame, it captures the leftmost area of the frame, expands, and fills the Y dimension. Because the fill option is specified as fill equals Y, it claims all the area that it wants and fills the Y dimension of its frame container frame. Because frame is itself packed with a plain pack method with no mention of a pack option, it takes the minimum space required to accommodate all of its child widgets. If you increase the size of the root window by pulling it down or sideways, you will see that all the buttons within frame do not fill or expand with the root window. The positioning of the B, C, and D buttons occurs on the basis of the side and fill options specified for each of them. The next 3 buttons after B, C, and D demonstrate the use of the expand option. A value of expand equals 1 means that the button moves its place on resizing the window. Buttons with no explicit expand options stay at their place and do not respond to changes in the size of their parent container. The best way to study this piece of code would be to resize the root window to see the effect that it has on various buttons. The anchor attribute provides a means to position a widget relative to a reference point. If the anchor attribute is not specified, the Pack Manager places the widget at the center of the available space or the packing box. The other options that are allowed include the 4 cardinal directions, N, S, E, and W, and a combination of any 2 directions. Therefore, valid values for the anchor attribute are center, N, S, E, W, NW, NE, SW, and SE. The value for most of the Tkinter Geometry Manager attributes can either be specified in capital letters without quotes or in small letters within quotes. We will use the Pack Geometry Manager in some of our projects. Therefore, it will be worthwhile to get acquainted with Pack and its options. The Pack Manager is ideally suited for the following two kinds of situation: placing widgets in a top-down manner, placing widgets side by side. Code 1.05.py shows an example of both of these scenarios. This code produces a GUI like this. Although you can create complicated layouts by nesting widgets in multiple frames, you will find the Grid Geometry Manager more suitable for most of the complex layouts. The Grid Geometry Manager. The Grid Geometry Manager is easy to understand and perhaps the most useful geometry manager in Tkinter. The central idea of the Grid Geometry Manager is to organize the container frame into a two-dimensional table, which is divided into a number of rows and columns. Each cell in the table can then be targeted to hold a widget. In this context, a cell is an intersection of imaginary rows and columns. Note that in the grid method, each cell can only hold one widget. However, widgets can be made to span multiple cells. Within each cell, you can further align the position of the widget using the sticky option. The sticky option decides how the widget is expanded. If its container cell is larger than the size of the widget that it contains, the sticky option can be specified using one or more of the N, S, E, and W options or the NW, NE, SW, and SE options. Not specifying stickiness defaults to stickiness to the center of the widget in the cell. Let's have a look at a code that illustrates some of the features of the Grid Geometry Manager. This is the code 1.06.py that generates the preceding GUI. This is a description of the code. Take a look at the grid position defined in terms of the row and column positions for an imaginary grid table spanning the entire frame. See how the use of sticky equals W on both the labels makes them stick on the left-hand side, thus resulting in a clean layout. The width of each column, or the height of each row, is automatically decided by the height or width of the widgets in the cell. Therefore, you need not worry about specifying the row or column width as equal. You can specify the width for widgets if you need that extra bit of control. You can use the sticky equals NSEW argument to make the widget expandable and fill the entire cell of the grid. In a more complex scenario, your widgets may span across multiple cells in the grid. To make a grid to span multiple cells, the grid method offers handy options such as row span and column span. Furthermore, you may often need to provide some padding between cells in the grid. The Grid Manager provides the Pad X and Pad Y options to provide padding that needs to be placed around a widget. Similarly, the iPad X and iPad Y options are used for internal padding. These options add padding within the widget itself. The default value of an external and internal padding is 0. Let's have a look at an example of the Grid Manager, where we use most of the common arguments to the grid method, such as row, column, pad X, pad Y, row span, and column span. Here is the code 1.07.py produces a GUI to demonstrate how to use the Grid Geometry Manager options. This is the code 1.07.py that generates the preceding GUI. Note how just 14 lines of the core Grid Manager code generate a complex layout, such as the one shown in the preceding output. On the contrary, developing this with the Pack Manager would have been much more tedious. Another grid option that you can sometimes use is the widget.grid_forget method. This method can be used to hide a widget from the screen. When you use this option, the widget still exists at its former location, but it becomes invisible. The hidden widget may be made visible again, but the grid options that you had originally assigned to the widget will be lost. Similarly, there is a widget.grid_remove method that removes the widget, except that in this case, when you make the widget visible again, all of its grid options will be restored. For a complete grid reference, type the following command in the Python shell. Now we will delve into configuring a grid's column and row sizes. Different widgets have different heights and widths, so when you specify the position of a widget in terms of rows and columns, the cell automatically expands to accommodate the widget. Normally, the height of all the grid rows is automatically adjusted to be the height of its tallest cell. Similarly, the width of all the grid columns is adjusted to be equal to the width of the widest widget cell. If you then want a smaller widget to fill a larger cell or to stay at any one side of the cell, you can use the sticky attribute on the widget to control this aspect. However, you can override this automatic sizing of columns and rows by using the following code. Use these to configure the options for a given widget W in either the nth column or the nth row, specifying values for the options, min size, pad, and weight. Note that the numbering of rows begins from 0 and not 1. The options available are as follows. Min size. This is the minimum size of a column or row in pixels. If there is no widget in a given column or row, the cell does not appear in spite of this min size specification. Pad. This is the external padding in pixels that will be added to the specified column or row over the size of the largest cell. Weight. This specifies the relative weight of a row or column and then distributes the extra space. This enables making the row or column stretchable. For example, the following code distributes 2/5 of the extra space to the first column and 3/5 to the second column. The column configure and row configure methods are often used to implement the dynamic resizing of widgets, especially on resizing the root window. You cannot use the grid and pack methods together in the same container window. If you try doing that, your program will raise an _tkinter.tcl error. The other options that are commonly used with place include width and anchor. Refer to the code in 1.08.py for a demonstration of the commonplace options. You may not see much of a difference between the absolute and relative positions simply by looking at the code or the window frame. However, if you try resizing the window, you will observe that the button placed does not change its coordinates, while the relative button changes its coordinates and size to accommodate the new size of the root window. For a complete place reference, type the following command in the Python shell. The Place Manager is rarely used because if you use it, you have to worry about the exact coordinates. If you make a minor change to a widget, it is very likely that you will have to change the XY values for other widgets as well, which can be very cumbersome. We will not use the Place Manager in our projects. However, knowing that options for coordinate-based placement exist can be helpful in certain situations. This concludes our discussion on geometry management in Tkinter. In this video, you had a look at how to implement the pack, grid, and place geometry managers. You also understood the strengths and weaknesses of each geometry manager. You learned that pack is suitable for simple sidewise or top-down widget placement. You also learned that the grid manager is best suited for the handling of complex layouts. You saw examples of the place geometry manager and explored the reasons behind why it is rarely used. In the next video, you'll be able to plan and execute different layouts for your programs using these Tkinter geometry managers.